Maybe I'm a little bit nostalgic, but there was a time when software development felt more like a craft. My father wrote mainframe code and could still talk about systems that he built 40 years ago as if they were living things. Today, software development is different. It's endless backlog lists, sprints, and boards with KPIs. It feels much more like a production line than an art. At the center of this shift is one company, Amazon. This is the story of how Amazon and Jeff Bezos helped turn software development into something that looks like a manufacturing production line. Jeff Bezos started Amazon as an online bookstore. This online bookstore expanded over the years into what is probably the largest retail platform in the world. That's what we all see. Amazon Prime, next day delivery, speed, efficiency, and a lot contributed to Amazon's success. But at its core, they mastered one thing, logistics, the ability to pick and pack and ship quickly and efficiently. Inside Amazon, everything is measured. Workers are tracked to the second, how fast they pick, how long they pause, whether they fall behind. If you miss targets too often, the system flags you automatically, and in some cases, managers rarely even intervene. It's so intense that stories emerged of workers relieving themselves in bottles just to keep up. In the distribution facilities, employee turnover is often cited at over 100% annually. That's what a fully optimized, KPI-driven system looks like. This is what lies behind Amazon's ability to deliver anything you want the next day. Now imagine applying that same logic, not to boxes, but to software. Quick timeout where I ask you to support the channel by clicking the subscribe button. If you are enjoying my videos, then click subscribe. Thanks a ton. Today, Amazon isn't just retail. It dominates cloud computing through AWS. They generate massive amounts of revenue through advertising, but they also have the de facto largest cloud solution business in the world with Amazon Web Services. It's reportedly controlling about 30% of the world's global cloud infrastructure. If we go back many years, early software was often built by individuals or very small teams. Tetris, the game, was built by one person. Civilization was made by fewer than 10 people. The complexity and size of teams has massively grown in all types of software development. Developers weren't just workers, they were specialists. Sometimes they were even closer to something akin to artists. This was a job that was clearly difficult, and the impact of these artists was immense. And it's no surprise, probably, that within tech, the term architect is widely used both in the software and infrastructure domains. What was also typical about software development was the waterfall model. It was an approach to software development that emphasized slow, thoughtful planning with a clear understanding of the requirements upfront. Detailed design happened well before coding even started, and everything was done in sequence. You designed, you built, you tested, you released. The goal wasn't speed, it was predictability. It was better to check an extra time to avoid releasing something that didn't work exactly as planned. And this made sense. When you were maintaining or developing anything for something as critical as a mainframe banking system, small mistakes could be catastrophic. These systems needed to be robust and maintainable over long time horizons. But it wasn't without its downsides. The time from release to release was long. It could be years between software updates. For the software developer, it also meant that roles were more specialized. The architects designed the systems, the developers wrote the code, QA tested the code, and operations ran and maintained the systems when they were released to production. Developers had high technical authority, but they had a limited say in what was being built. There was a massive technical authority to their role. But then things started to change. They center around a couple of terms that you've probably all heard of: sprints, agile, scrum, DevOps. The timing and origin of these terms are a little bit different, but within tech, they all gelled into a new philosophy around how to develop software. The old model of predict, plan, build was replaced with something else, which was more build, release, and adapt. The priority wasn't stability or control or predictability anymore. It was speed and iteration and integration. Companies went from thinking up these big monolithic systems and rethinking them, on 5-year cycles to a much faster model that emphasized building and often the term, minimum viable product. They released it, they got user response rapidly, they adjusted, they patched, and then they prioritized new features and repeated over and over and over again. What this meant was that roles collapsed. So developers didn't just build anymore, they operated. DevOps literally has a core tenet that says, if you build it, you also run it. Teams were also made smaller, so Amazon called it the two-pizza team principle. The idea was to make sure that accountability was clear and decision pathways were simplified. It resulted in a couple of things that I personally hate about modern games, for example, which is first-day patches. But in a world of apps and APIs and all the rest, this iterative speed and correction-based model has proven to be incredibly effective. And Amazon didn't just adopt these ideas. They combined them with something else. They implemented the thinking of the fulfillment center. They built a system where software development behaves like operations. And once software becomes operations, it becomes measurable. And once it's measurable, it becomes optimized. And once it's optimized, that's when things start looking like a production line. Amazon tech teams are known for being massively metric-driven and performance-focused, much like the employees of fulfillment centers. Development and release cycles are notoriously short. Sprints are constant, and as a software developer, your output is measured on multiple KPIs. And when quality or speed or quantity is not up to the standard, the consequences are clear and measurable. Turnover is often described as higher than industry averages at Amazon. And all of this has worked. Amazon is dominant in cloud computing and has proven that this approach is highly profitable. Unsurprisingly, a lot, if not all major tech companies in some way, shape or form have adopted both agile, Scrum and DevOps logics together with varying degrees of data-driven manufacturing style management. At a human level though, the change has been huge. By collapsing the roles of architects and developers and testers and ops people, the role of the specialist engineer hasn't disappeared, but it's definitely changed. Where 30 years ago there was a reverence for those kind of engineers and what they did that nobody else understood, today it's more of a generalist type role. The transition from this monolithic thinking into buckets and features and blocks has likewise contributed to reducing the reliance on the all-seeing, all-knowing engineer. We can get into a long conversation about technical debt, but my father kept getting calls well beyond his retirement to help out on something with the mainframe because he was the only one left who knew how the things were done. Today, systems are designed so that no single person is indispensable. And the KPI regime? This is the final piece of the puzzle. KPIs aren't the problem on their own, but in a fully measured system, the engineer starts to look less like a creator and more like a unit of output. Because under a regime like this, the engineer is deployed as a person on a production line. There's a skill required, there's an important job to be done, but the dependency on the individual is less. The individual becomes more interchangeable. You can swap people in and out with less disruption. People are justifiably worried about how AI will take software developers' jobs. The irony to me, though, is that the foundations for turning software developers into readily replaceable cogs in a wheel were laid long before AI as a term really caught hold. Companies like Amazon, with their approach, which has led to innovation and productivity increases for clients and features and benefits for consumers and profits for shareholders, have also taken what was once considered an almost noble scientific profession and transformed it into a commodity. There's still a need for those engineers with deep, deep skill, but more and more, those commodity roles are the ones that are disappearing. And it all started in a fulfillment center with someone packing books into boxes and someone else thinking, could software development be run like this? Those are my thoughts. I am curious for those of you that have a software development background, who know Turbo, Pascal, C#, and all the rest. Share your thoughts in the comments. Remember to subscribe. See you soon.